Guys, hope all of you are doing great out there. I'd like to welcome each and every one of us to my channel of Honesty Sciences and Mathematics TV channel. Today we're going to look at the second bit of the concept of coordination by proteins. And these are some of the, of course, examples of ligands or biological molecules which we said are going to be combining with metals to form some important biocompounds or complexes which are going to be essential in biological systems. And in our last discussion, I had basically given a specific categorization or classification of proteins in terms of their specific structure. And I had given three sets of this specific classification for primary, secondary, and the tertiary form of proteins. And in this case, we had basically given some of the examples and the structural formations of these specific three categories. Now, in a sense, I stated that the primary set of proteins are going to be formed by a linear sequence of amino acids, which we gave an example in terms of an illustration from that specific video. Now, to differentiate between the first and the second one, we said that the second is going to be formed by what we refer to as foldings into some of the shapes like the alpha helices and the beta sheets, which basically we had given also in terms of an illustration that is going to be differentiating between the primary and second. And lastly, we said that for the tertiary kind of proteins, these are going to be foldings which are going to be three-dimensional kind of foldings, which are going to be basically formed by this specific range of combination of this particular set of polypeptide chains. Now, in a sense, we are going to see that we can give examples of these specific types of proteins, which are going to be perhaps given in terms of enzymes. And in a sense, I said that there are going to be specific coordination centers which are going to be used, especially in the formation of these specific peptide chains, which are going to be forming this set of proteins. Now, given for this specific case, two examples for this particular illustration. So for the first one is going to be assisting us try to describe these specific functional groups of amino acids and some of the metal centers which we're going to come across, especially for zinc, that is going to assist us try to describe a situation whereby we're going to have a combination of this amino acid and a metal. And this is going to be assisting us try to describe a situation for this specific carbonic anhydrase, of course, with the zinc. Now, in a sense, we're going to see that if we're going to have an enzyme, of course, combining with a substrate to form an enzyme substrate combination, there are some states whereby we are going to see that these specific metals are going to be consisting of some of the sites which are not going to be occupied. And in this case, these sites can as well be occupied by ligands such as water. Now, in a sense, we are going to see that such a kind of states whereby these specific sites are going to be occupied by ligands are going to be referred to as resting states. Now, we shall give one of the example of this specific state for the resting states, which is going to be given as a carbonic anhydrase with a zinc given as the first example above. And therefore, that's going to be more clearer for us. Now, in a sense, I've just indicated this one, and we're going to be using this specific set of carbon-oxygen bonds in trying to show the mechanism between these specific states, which I've just referred to as, of course, a resting state, that is going to be involving zinc metalloenzyme, which is going to be given by this specific example. Perhaps we can just show the mechanism for this, and this is going to be assisting us try to describe the coordinatively unsaturated or open coordination sites in metal complexes that is going to be having fewer ligands, and therefore it's going to be preferred for maximum coordination, and therefore trying to create some of the, of course, ligands which they are going to be binding with in this specific resting state given as such. Now, for the lower example, this is going to be a protein, of course, an amino acid that we refer to as cysteine. And cysteine is going to be combining with another similar molecule of cysteine through the process of oxidation in trying to form this specific, of course, a complex which I've given on my right. And of our interest in this lower case particularly was to show the disulfide bond, which is going to be realized from the combination of the two. And this is going to be through this specific diolate center, which is going to be this one and this one in particular. So for the lower case, that is going to be, I presume, comprehensive. But for the uppercase, we are going to be showing the mechanism which is going to be involved in trying to, of course, describe this resting state of this specific type of zinc metalloenzyme. Now, for this first case, we're going to show this specific enzyme consisting of that specific water molecule, and therefore this is going to be in a resting state whereby it's going to be described as such. So it's going to undergo the first stage in this specific case whereby it's going to be losing a proton given as such, and this is going to be resulting in this specific intermediate stage which we're going to see given above. And from this one, this is going to be of course attacking at this specific point, and this point is going to be opening up, and therefore it's going to be creating an intermediate that's going to be of course attached at this specific point given as such. and therefore this is going to be resulting in the second stage. So we shall have an involvement of this specific kind of course a compound being given as such, and therefore we shall have this specific stage resulting in this formation of this specific intermediate at the third stage. And as we can see from this, there's particularly a sequential extension of this specific section for water, and this is going to be, if you compare stage 1 and 3, there's going to be a replacement of this specific of course section for water and this one through this specific mechanism, and therefore we're going to see that this specific center is going to be attacked by this particular form of linear electrons which are going to be attacking at this specific point, and this is going to be forming a living group, and therefore we shall have this one forming a living group at this lower section given as such. Now in this case, this is going to be resulting in this specific state, but of essence for us to understand that there was this specific transition for this specific of course molecule to be attached at this specific point, and therefore the last stage is going to be resulting in this resting stage which we have given from our first example. So this is going to be basically returning to its initial states which we have given as such, and therefore this is going to be describing an example whereby of course an enzyme is going to be occupied by a ligand at the resting stage, which is going to be a temporary situation that can be given by this specific carbonic anhydrase with the zinc as shown above. And as I said, this is going to be describing coordinatively unsaturated situation for this specific open sites, which we are going to be giving in terms of various examples in our subsequent videos, which we perhaps can look at this specific case. So I'm just going to be giving a general case for the perhaps an occupied, what we refer to as an occupied orbital, which can be given as, so I'm going to have a metal ligand combination given as such. So in this case, we shall have an empty orbital which is going to be particularly occupied by the substrate in this equation of enzyme plus substrate which are given, which is going to be forming enzyme substrate, and this situation is going to be regarded as an inactive form of this specific type of course complex, but we shall have this one which is going to be given in terms of a metal, a ligand, and another ligand which is going to be joined above, and therefore we shall have a specific set of what we refer to as of course this is specific center which is going to be charged given as such, and therefore this is going to be a state that we're going to be referring to as a fully functional state for a metal ligand combination given as such. So this is going to be in essence providing for us such a scenario as the one that we have described above for this specific type of an enzyme, and we're going to come across them in our various discussions as we're going to go by in this specific discussion of coordination by various types of biologically important of course ligands as we go by. So that is it for now, guys. Kindly check our description boxes for various links of other videos, engage us in the comment section, and also ring that notification bell for different updates on different subjects of math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.